Hello and happy Math Day. This is the second of 4 video primers in which I'll be covering some of the essential junior high math skills related to the idea of rational numbers. In this video, we'll review the concept of adding and subtracting rational numbers, otherwise known as fractions. Now, of course, it's important to deal with and manipulate fractions. Think of working with recipes or in construction, for example, but also understand that the work we'll be doing here serves a much higher purpose, which is to understand how numbers and their values and representations relate to each other and how we can manipulate them in different ways. Trust me when I tell you that we will never be calculating 3/8 of 11/17 and then adding 43/72 in the real world. But there is a reason behind the madness, and the fun begins after you're able to do this relatively simple arithmetic. As in all of these primers, this lesson is meant to be interactive, and you can find a link to the PDF worksheets and the solutions to the practice problems down below. I do encourage you to print these pages out and follow along as we work through some examples together. So where have we come from and where are we headed? In grade 7, you learned how to add and subtract positive fractions, okay? Next year in grade 8, you learned how to multiply and divide those fractions. And then in grade 9, you took another concept you learned in grade 7, which was adding and subtracting and multiplying and dividing positive and negative integers. And then you applied that knowledge and understanding to dealing with adding, subtracting, multiplying, and dividing positive and negative fractions. So some of the things that you might recall learning is that a positive number minus a negative number was the same thing as adding the positive version of that number you were subtracting, right? A positive minus a negative is like adding the positive. And another thing you might remember is that if you have two negative numbers multiplied by each other, a negative times a negative gives you a positive, right? So these are a couple of the ideas that we'll be applying when it comes to rational numbers. The key idea to knowing how to add and subtract fractions has to do with this idea of the common denominator. Okay? Common denominators are important because you can't add and subtract fractions unless they both have that same number on the bottom of the fraction line. And so to deal with this idea of a common denominator, you'll need to know how to simplify fractions and how to deal with equivalent fractions. So let's jump right in and start with some examples. To begin, we'll add and subtract various combinations of the fraction 1/2 and 3/4, okay? And we're using the same two fractions in different combinations just to see if we can start building up some understanding of the patterns that are involved here. So 1/2 plus 3/4 cannot be added straight away. We need to deal with this fraction here, 1/2, and bump it up to something that looks more like that second fraction. To do that, we're going to multiply the top and bottom by 2 to get the equivalent fraction of 2/4. So 2/4 plus 3/4. Now we have common denominators. Now we can simply go 2 plus 3 on the top. The 4 stays the same. And this will be what? 5/4 or 5/4. All right, let's try -1/2 plus 3/4. Well, once again, we're going to bump up that first fraction, -1/2, to a fraction out of 4. Add to it 3/4. And now we're ready simply to add 3 to -2 and simplify to 1/4 like that. All right, so now we'll go to 1/2 plus -3/4. And this will be, we're going to change this a little bit. The 1/2 once again becomes 2/4. Plus minus 3/4, the same as simply subtracting 3/4 straight away. So when we simplify that, we're going to get 2 minus 3/4, or -1/4. And finally, the last example, let's once again start by converting -1/2 into a fraction out of 4. So we're going to get -2/4 plus -3/4 is the same as simply subtracting 3/4 straight away. And so when we rearrange this and simplify, we're going to get -2 minus 3 all over 4. And when we simplify that mess, we're going to get -5/4. All right. Cool. So some simple examples just to get us started and to get our heads in the game. Let's take a few fractions now and begin to subtract them, right? And you can see that subtracting a fraction and adding a subtraction, depending on whether or not what you're adding or subtracting is positive or negative, are very closely related, right? So we're going to see a bit of repetition here. We're using the fractions 2/3 and 1/4 this time. And this time, when we're looking for equivalent fractions, it looks like we're going to be looking for a common denominator of, looks like 12. 12 is the smallest number that both 3 and 4 are able to divide in. So in every case here, we're going to be multiplying the first fraction times 4 and the second fraction times 3, okay? All across here, here, and here to get a common denominator of 12. So 2/3 is the same as 8/12 minus 1/4, which is the same as 3/12. So 8 minus 3 over 12 will give us, looks like 5/12. How about negative 2/3 minus 1/4? Well, we have a negative number and we're taking even more away from that. So it's going to be even more negative, right? So this is what I'm talking about when we're talking about how numbers work. A negative number minus another number is going to make it even more negative. So negative 2/3 is going to become negative 8/12 minus 1/4, which is going to be 3/12. And so when we put this all together, we're going to get negative 8 minus 3 over 12, which is equal to what? Negative 11/12. And now let's subtract negative 1/4 from 2/3. Well, we start off the same way. 2/3 is the same as 8 over 12. Minus a negative number is the same as adding that number. And 1/4 is 3/12. And so now when we simplify that, we get 8 plus 3 all over 12, and that's going to be 11/12. And the last example, negative 2/3 minus negative 1/4. First step, let's convert 2/3 into a fraction out of 8. Negative 8/12 minus, well, minus a negative is positive, right? So 1/4 is going to become 3/12. And so we're going to get negative 8 plus 3 all over 12 equals negative 5/12. Cool, we're done. So here's a good time to remind ourselves of a couple of things in terms of, again, understanding how the numbers work. If you take a positive number and you add another positive number, you're going to get a number that's even more positive. Okay, you're going to get a bigger number. So positive plus a positive is always going to give you a bigger number, the sum of those two. If you take a negative number and you add another negative number to it, you're going to become even more negative. Okay? Two negative numbers together gives you something even further to the left of the number line. When you take a positive number and you subtract from it a negative number, that's going to be the same as adding the positive version of that number in the first place. So once again, you're going to get an even more positive number. A number minus a negative is going to be even more positive, right? And finally, what if you have a negative number and you subtract from it a negative? Well, that's the same as a negative number plus a positive number. Do you know whether the number is going to be bigger or smaller than the original? Well, it all depends on how big that one is to begin with. And that's what we mean when we talk about looking at patterns and understanding how numbers work when we're manipulating with each other. Let's try some slightly harder examples here. Mixed numbers, and generally speaking, there's two ways to deal with mixed numbers. First way is probably the easiest in most cases, but I just want you to know that sometimes there are different ways to approach the problem, and depending on the actual numbers you're working on, one might be easier or harder than the other one. So the first way to deal with this is to convert both of these numbers into improper fractions, okay? So we convert a mixed number into an improper fraction by taking the leading integer, multiplying it by the denominator, and adding the numerator, and then dividing the whole mess by the original denominator. Do that to the second side too. So subtract 4 times 4 plus 1 all over 4. And this is going to become, what is it, 16, 17, 19 eighths minus 17 quarters. So there's our first step. We've converted the mixed number into an improper fraction. Once they're in an improper fraction, then we can deal with the denominator issue. You'll see that that second fraction needs to be bumped up to a common denominator out of 8. So this is going to become 19/8 minus, well, 2 times 17 is 34 over 8. And when you do the math, we're going to get what? Negative 15 over 8. So that's one way to deal with this problem, but I want you to know that there is another. What if we take the leading integers and we were to subtract them and then add to that the subtraction operation of the fraction? What do I mean by that? Well, 2 3/8 minus 4 1/4 is really the same as 2 minus 4. There's the leading coefficients of the fractions in front of the fractions. And then on top of that, adding the 3/8 minus 1/4. So take a look at that and see if it doesn't make sense. Remember that negative, let's say 2 1/4 is the same as negative 2 plus negative 1/4, right? So that's why I can have the plus sign there, is because I'm breaking out the parts of the negative number. Two negative numbers together make an even more negative number. So what are we going to get? Well, 2 minus 4 is negative 2. And 3/8 minus, it looks like we need to convert that second fraction into a fraction out of 8. So we're going to get 3/8 minus, what is it, 2/8, like that. Negative 2 plus, well, 3/8 minus 2/8 is simply 1/8. So negative 2 plus an 8, we're going to go 1/8 closer towards the 0 on the number line, is going to become negative 1 7/8. And I'm not sure that it's perfectly obvious that negative 1 7/8 is negative 15/8. If we converted this into an improper fraction, we get negative 1 times 8 plus 7, which is 15 over 8. We do get the exact same thing as over there, right? So which one is easier? Up to you to choose. It's not always as easy as this, so I think the go-to method is probably to convert to a improper fraction and then work through it that way. Let's try another example. Let's do it both ways as well. And so we'll begin by converting each side into their improper fractional form. So on the left side, we'll get negative 3 times 5 plus 2 all over 5. Minus a negative is like adding, so we're going to put a plus operator. 4 times 7 plus 1 all over 7. And if we were to simplify that a little bit, we get what? 3 times 5 plus 2 is negative 17 over 5 plus, looks like 29 over 7. All right. So now we're stuck with the denominator issue here. We need a common denominator between 5 and 7. And I think the smallest one we'll get is 35. So we're going to bump up the left side to 35 by multiplying it by 7. So negative 7 times 17 over 35. And we're going to bump up the right side by multiplying it by 5. So 5 times 29 over 35. And when we simplify this, I think we'll get negative 119 over 35 plus 5 times 29 is 1/2 of 10 times 29. 10 times 29 is 290. Half of that is what? 145 over 35. Cool. And then finally, negative 119 plus 45 is 26 over 35. Now, we get a positive answer here, right? Does that make sense? Well, on this side, we have negative, but we are subtracting another negative. And so that's going to be like adding. So we're going to be adding a number to the negative. What kind of number? Well, straight away, you can see that a 4 is greater than a 3. So we should get a positive number out of here. Not going to be a very big one. In fact, it's going to be less than 1, but we do get a positive value, and that's good. That's what I mean by looking at the numbers and seeing how they work and making sure that your answer makes sense in the big scheme of things. Well, I said that there's another way to do this, and I think in this case it's actually more difficult, but we're going to bluster through it just to show you. What I'm going to do is I'm going to subtract the integer numbers first, and then I'm going to subtract the fractional numbers. So to subtract the integer numbers, I'm going to get negative 3 minus negative 4 is the same as plus 4. Okay, so negative 3 plus 4. And now I'm going to add to that the subtraction that I get when I subtract -2/5. Again, minus a negative, so plus 1/7. Well, the first part's pretty easy. -3 plus 4 is going to give us +1, to which we're going to add whatever happens inside the brackets. Now, inside the brackets, we have -2/5 plus a seventh. And it's pretty clear that we need that lowest common denominator that'll be common between 5 and 7. And in that case, it's going to be 35, because 5 times 7 is 35. So we're going to put 35 pretty confidently in the denominator. To get 5 to equal 35, we multiplied it by 7. So 2 times 7 will be -14. And we multiplied 7 by 5 to bump it up to a fraction out of 35. So 1 times 5 is simply 5, like that. All right. So simplifying a bit, we still have the +1. And -14 plus 5 would be -9/35. And now we're stuck again because we don't have a fraction out of 35, but we can convert 1 to a fraction out of 35 by simply going 35 over 35. Any number divided by itself is 1 minus 9/35. Bringing it home now, 35 minus 9 is positive 26 over 35. And look at that, we have the same answer. So here we did the same question in two different ways. You get the same result. Which one's easier? Which one's harder? Well, you know what? I urge you to give it a try and see which one works for you. You should be comfortable doing it both ways. It just builds up your ability to deal with numbers efficiently and accurately. So just to make a point here, I want to take a look at this solution we have, and I want to do it slightly differently. Okay. Notice where the negative sign is. It sort of looks like it's up on the numerator on the top. See the negative sign there and the negative sign there? Well, what happens if instead of assigning the negative to the numerator, we assigned the negative to the denominator? What do I mean by that? Well, what I mean is instead of -3 times 5 plus 2, let's say we had +3 times 5 plus 2 over -5. All right? And then the other side will be the same. 4 times 7 plus 1 all over 7, okay? The difference here is the location of the negative sign. In this example up on the top, it's in the numerator. Now I'm going to put it in the denominator and see if that has any effect on anything. Well, carrying this to the next conclusion, we're still going to get 3 times 5 plus 2, which is 17, but over -5. Plus, still going to get 29 over 7. So once we set it up this way, we're going to continue in the same line. The denominator, though, the lowest common denominator, is going to be a little bit different. Instead of +35, we need a common denominator between -5 and 7, and we're going to make that common denominator -35. And so to get a -35 out of a -5, we've got to multiply top and bottom, of course, by 7 still. So we're going to get 119 over -35. Okay. We just multiplied this by 7. Okay. But to get a common denominator of -35 out of that, we're going to have to multiply by -5. So plus, and then I'm going to put in brackets here because -5 times 29 is going to be -145 over, and we wanted that common denominator of -35. All right. And remember, what we're doing here is showing you that it doesn't matter where you put the negative sign. On this example here, we had it at the top or in front of the overall term there. But in this case, we'll put the negative sign in the denominator. I'm just proving to you that it does not matter where it goes. We are going to get 119 minus 145 on the top and a common denominator of -35 on the bottom. And when we finish that off, we're going to get -26 over -35. And of course, a negative divided by a negative is positive, and so this simplifies as 35 like that. All right. Same answer as we got there. It's the exact same answer. It doesn't matter where you express the negativity of a term, whether it's in the numerator or the denominator, it all works out the same. All right, so let's tackle a couple of more, slightly more difficult questions here, okay? And I'll give you an example where sometimes it makes sense to deal with the coefficients in front of the fraction, those numbers in front of the fractions first and then the fractions separately. And in some cases, it makes sense just to convert everything to improper fractions and go from there. All right, so in the first case here, let's deal with those numbers to begin with. We're going to get -1 minus a negative is the same as adding a positive, so +2 minus 3. There's the leading coefficient in front of the fractional terms, the integers in front of the fractions. And now we can deal with the fractions a little bit more simply here. We're going to get -3/5. Remember, the negative here applies not only to the 1, but also to the fraction. It's overall negative. Okay, so -3/5 plus 1/3 minus 2/7. Well, -1 plus 2 minus 3 is going to be -2, to which we're going to add the results of -3/5 plus 1/3 minus 2/7. And so what we're going to do is think of a common denominator that has 5, 3, and 7 as a factor. And the smallest version of that I can figure out would be 105. 3 over 5 is the same as 3 times 21. So there's going to be the 63 over 105. Remember, I got the 105 by going 5 times 3 times 7, right? And since the 5's already in there, I got to multiply the numerator by 3 times 7, or 21. So 21 times 3 is 63, plus 1 over 3, we need to convert to a fraction out of 65, so we're going to multiply by 35. So plus 35, 1/5. And subtract from that, well, we're going to bump up the 2 over 7 to make 30 over 105, like that. Take a moment and try to follow what we did step by step. I skipped a couple of things, but by this point in your mathematical careers, you should be able to combine a number of steps into one. So we still have -2 plus -63 plus 35 minus 30 all over 105. And when I do that math, it looks like I get, well, -63 plus 35 minus 30 looks like it's going to be -58. And now I have a negative number with another negative number added to it. So it's going to be simply -2 and 58 105s. All right. All right, not too bad. All right, so how can we deal with this kind of complication? Now we need to know what that question mark is. There is a number that fits in there. It's an integer. Well, it's a number between 1 and 9. And you could do it, I guess, by trial and error and, substitute a 1 in there, see if it works, and a 2 and a 3 and so on. But that's not very mathematical. So let's see if we can figure out a mathematical way to do this. Well, let's take a look at this whole number here. If we know what that fraction is, then we know what that question mark is, right? So 4/5 plus something equals 22/15. That means that that something, question mark over 3, must equal, well, that first fraction, 22 over 15, minus 4/5. All right? If 4/5 plus something equals 22/15, then that something must equal 22/15 minus 4/5. So something thirds, question mark thirds, we don't know what that is. Okay, it's going to be equal to, let's bump this up to a common denominator out of 15. So 22 minus 12, because 4/5 is the same as 12/15. And so question mark over 3 equals, well, 22 minus 12 is 10. And 15, like that. And now we can figure this out pretty easily. Something over 3 is the same as 10 over 15. So what do we do here? Well, there's a couple of ways to approach it. One is just intuitively. If I take this mess here and I divide it by 5, I'm going to get 2 over 3. And now notice that this fraction looks like this fraction, and I know that my question mark is going to be equal to 3. Okay? But how would we do this more algebraically? Well, what I would say is that 15 times some number, question mark, equals 3 times 10. I'm doing the cross multiplying thing here. And therefore, question mark is going to be 30 divided by 15, question mark equals. just a different way of looking at adding and subtracting fractions, and an example of how we can ask trickier questions using the basic facts and skills and techniques that you already have. Well, in this question here, we've got an unknown there, and we can start using letter values to represent unknown values here. So if 1/2 plus something equals 5/6, that means that that's something, and let's just call it x, okay? X must equal 5/6 minus 1/2. Well, if that's the case, then 5/6 minus 3/6 must also be true, because we're just bumping up the 1/2 into an equivalent fraction of 3/6. And then this must equal 2/6, right? 5 minus 3. And that can simplify to 1/3. And I think we have our answer right there. X must equal to 1/3. And let's just try. Let's just verify and make sure that this is true. 1/2 plus 1/3 equals 5/6. All right, so the common denominator there will be a 6. So I'm going to have 3/6 plus the common denominator here. There'll be a 2/6 equals 5/6. And yeah, it looks like we're on the right track. 5/6 equals 5/6. We have proven it to be correct. So there's your answer for this one. All right. And now we're leaving the hardest to last. This is using skills you already have. You know how to add and subtract fractions. We are now thinking deeply about simple things, which is a common theme in math at high school level. Well, let's begin by assigning some letters to these question marks, because in math we like to use well, we're quite fond of using x and y's for unknown values. So x/3 plus y/4 equals 5/3. Okay. Well, once we have this, we can figure stuff out. We don't like fractions. We don't like those fractions there. So what we're going to do now is a little technique that I call clearing the fractions. What we're going to do is we're going to multiply this entire equation by 12/1. All right. So if you have an equation and you multiply both the left side and the right side of the equal sign by the same factor, you're not going to change the end result. You're not going to change the values for your unknowns or your variables. You're just changing how it looks. All right. So it's like saying, well, if 2x equals 4 and I multiply that by 2, then 4x equals 8. In both cases, x is going to be equal to 2, isn't it? It doesn't matter whether I use the simplified form or whether I use that form multiplied by a factor, right? So I'm going to multiply by 12/1. And what I'm going to get is this. I'm going to get 12x/3 plus 12y/4 equals 12 times 5/3. All right. So remember, with multiplying fractions, you just multiply straight through. I'm asking you to remember how to multiply fractions, which is really the subject of the next primer in this series. But you might recall that to multiply fractions, you simply multiply the denominators across and multiply the numerators across. All right, so let's simplify. 12x/3 is the same as 4x. 12y/4 is the same as 3y. And 12/3 times 5 is the same as 4. Okay? Because these kind of, cancel out, and you can do that kind of thing to it. So now I've got 4x plus 3y equals 20. So how shall we deal with an equation with two variables? Well, we've got a couple of options. Actually, we have 3 options we can do here to help simplify. In case number 1, let's let x equal to 1. All right? If x equals to 1, then 4 times 1 plus 3y would equal 20. And you could isolate for the y and figure out a value for y that would work. And then once you had that y value, you're done. You know what x is, you know what y is, and you're good to go. And so we can do the same thing now with y. Instead of x equal, let's make y equal 1. Because if y equaled 1, then we get 4 times x plus 3 times 1, or 3, equals 20. And now you could solve for the x value. So you get an x equals something. Just like over here, you got y equals something. But there's one more option here. What if x equaled y? That is, x and y were the same number. That would give you another result. So where you see an x, it's really a y, or where you see a y, it's really an x. And if you simplify it, and again, we're looking at this equation here, 4x, and because y equals x, I can just say 3x instead of 3y equals 20. In other words, 7x equals 20, x equals 20 over 7. We can figure out yet another value for x and y that'll work. So what I'm saying here is that there are lots of different possible answers for x and y's. And I put this question in here just to give you a bit of an example of where we're going to be headed to in grade 10 math. If you don't quite understand this yet, don't worry about it. You will soon enough. That is the very purpose of grade 10 math. All right, we are done the sample questions that we did together here. I have a number of practice questions for you, starting off simply and then getting a little bit more difficult as we move along. Space for you to write some notes if you want to remind yourself of how to do stuff. Okay, nothing too difficult. Why don't you go and give these a try? You'll find the solutions in a PDF file down below somewhere. Happy mathing, folks.